Hey everyone. We recently launched Exercism Insiders, which is our behind the scenes extra features reward program for everyone that donates or contributes to Exercism. It's our way of saying thank you to everyone that supports us. But one of the problems is you don't really get to see what's in our behind the scenes content unless you actually join Insiders. So I thought it would be nice just to take one of the videos we're making, put it out on YouTube, let you all see what sort of content you can access from Insiders. If you want to join Insiders, you can just donate, set up a recurring donation of $10 or more a month through Exercism, and that'll give you access to things like dark mode, our ChatGPT integration, some extra mentoring slots, and the private Discord channel, extra badges, and all sorts of content like this. So if you want to become more part of Exercism and want to support us, Insiders is the way to go. Hope you enjoy the video. Hey everyone. So Erik and I just wanted to chat for a few minutes about the stuff I mentioned in the Insiders update yesterday about detecting different concepts and how we can use them. This is totally unscripted. Erik's got a little bit of code to show. We were just having some discussions before, and Erik was like, we should just record these discussions. They're useful. So hi, Erik. How are you?
Hi.
Erik's down here to my left, so I'll be looking down a lot. But yeah, this is hopefully just interesting for everyone, for maintainers or people that contribute code to Exercism. Hopefully this acts as a bit of a guidance on stuff you can be doing. So just a really brief introduction. So we have obviously within Exercism, you'll all know the concept of concepts, but we want to be extending this a bit more now so that we can detect what exercises, what concepts different solutions are using. So we're going to take the example of recursion, which we're going to use a lot in this. So is this solution using recursion, yes or no? If they are, we can then do various things. We can tag that solution as recursion. People can filter in the community solutions by things that use recursion and find this solution. We can also recommend approaches based on that tag. We can also say, hey, you're using recursion, you might want to try using a different method instead. That might work better the other way around, where we want people to try recursion. And so we detect that they're not using recursion and then suggest something. It's also good for new track trophies, which is where this came out of. Erik was wanting to add custom track trophies, and detecting whether people are doing something like recursion is a fun track trophy. Any other uses we can use this for, Erik? Off the top of your head?
I think you've covered them all.
Okay, cool. So that's the general principle. So Erik just put a quick proof of concept together, which we're going to look at in a minute as well. But yeah, general idea, have the ability to detect concepts, save them to a database, use them in other places around the site. That's the fundamental set of things. So the discussion Erik and I were just having before we started was, should this go into the analyzer or the representer? As normal, Erik and I are both quite pragmatic about these things. My instinct is the analyzer, because I feel like the analyzer sort of runs once per solution and does stuff.
But the representative does that too. But
whereas the representative does that, but yeah, groups things. It's a bit of a difficult one. I don't know.
Semantically, analyzer makes more sense because it's analyzing your code. It's far more broad than the representative, which is a very specific targeted thing. With all that said, my demo is actually using the representer, but that's for very pragmatic reasons, because I knew the way that I wanted to implement this was by, well, I'll show you in a minute, but the setup that I used for the representer better fit that than the analyzer, although the analyzer can do it equally as well. But this was just easier because I only wanted to get a proof of concept out. So
I did suggest to Erik that we do both, and he shouted at me.
No,
we allow it in both. So we're not allowed to do that. We have to choose one or the other. So we'll do a write-up afterwards and we'll decide. I'm going to think about it a bit this afternoon. I can see pros and cons for both. I mean, analyzer, obviously we mess around with ASTs already, so that's a sensible thing. But I'm aware that there are some tracks that don't do AST manipulation in the analyzer. They just use like linters and stuff. Whereas,
But you could use it for a representative. So
yeah, exactly.
Yeah. I don't know how people implement these things.
There's also sort of there's an opportunity for us to put a representative together for every track, which does a sort of like one-to-one, takes whatever comes in and sends it out as the representation to give us a starting point for every track. We could just do something like normalize white space. That would be quite a low-hanging fruit for us to do, and then that would mean every track had that, and then there would be all of the boilerplate stuff there for somebody then to add the AST detection for the concept. So that might be another reason to do representers. I have a question that just occurred to me as I was talking, Erik, before we dig in, which is we're talking about these as concepts, and obviously that word has quite a specific word within Exercism. Are these things actually concepts, or are they tags or something that we have?
So my very first thought was tags, and then I just went with concept because it was like, this is something that I know. But I was already moving back. Well, it's a POC, so I didn't refactor anything basically. But tags might be better because you're not linked, tied to the concepts, so you might be more general. So I could imagine it being tagged as inefficient, which isn't really a concept, or efficient. Maybe let's start positive. So we can do all sorts of things, but
we could do both as well. We could have a tag and a concept. This uses these concepts. That's one thing, and this can be tagged in certain ways, and then we can use those in different places as well.
Yeah, as long as it's clear for the user that there isn't a distinction between them. So I don't know.
Yeah, I mean, they're probably not going to get exposed to this stuff as much. No. It's more like internally how we do it, I guess.
Yeah, but I considered tag
before. Yeah, so before Erik jumps in, so I'm aware I'm saying that a lot. What we want to do is have a little bit of a project that Erik's just going to run over the next, like, I don't know, month or whatever, maybe throughout August, and basically try and get every track to do add a recursion detector to their representer. Now, there are a couple of languages, assembly or something, where recursion detection is probably not an interesting thing to do. But certainly for most languages, I think it's going to be quite a fun, valuable thing. And then it means that everyone can be sharing knowledge on this. So that's going to be sort of the fun project that comes out of this. And then we'll add functionality to the website that makes some use of that. So there'll be some immediate tangible benefit from that. And then we can start looking at adding other concepts or tags, or whatever they are, on the back of that. So we'll put a forum post together and a blog post. I'll link this video to it as well, and you can see our wonderings.
So just Erik, shall I shut up to start, there's already a caveat that I can only really do this well if the language offers support to parse an AST. And not all languages have that easily available.
That's true.
So I
did wonder
with Recursion because I'm familiar with the representer, but I also chose C# because it is very, very easy to work with the AST. Whereas I know that for some tracks, for a long time, I'm not sure if they still do, but Kotlin didn't even expose their compiler API. So you couldn't actually get to the internals. Maybe there was a library somewhere out there. There might be other languages too that have something like that, but there could be issues. But
so one of the nice things about recursion is I reckon you can do recursion through some sort of regex, or maybe not regex, some sort of text.
You didn't want to parse languages with regex.
No, but you could, maybe not regex, but certainly with text parsing you could do it. Especially if you pre-format, so you've got sensible indenting first, you could definitely do it. But it's one of the nice things about recursion is that it feels, and I know it won't be 100% foolproof, but it feels like, it feels like a low-hanging fruit. And to give you an idea of some of the other things as well, so Erik and I we've talked about using detecting whether someone's using like, a switch statement or an if statement would be another thing. We also talked yesterday about whether people are using metaprogramming. So, are they using reflection in C# or define method or whatever in Ruby? There was it grains? I think it was grains. The exercise, and Erik was saying you can check to see whether they're using the exponent operator.
The context there was what type of concepts or tags or whatever should we detect? Because my POC just detected a couple like for loops and if statements too, because they were easy to implement. It took me a minute or so I just implemented those, which is a horrible way to implement things because that's how we have the null pointer exceptions, because it was easy to implement. But anyways, for most of the exercise, it doesn't really matter if you're using an if statement. So if you're looking at, I don't know, alphamatics, whether or not you're using an if statement, that doesn't really matter much. But for example, for grains, you have a couple of solutions. But in general, there's one that is mathy, where you just do a calculation. And there's one that usually involves either recursion or iterating over a sequence or something like that. So there it could be important whether you're not using the exponent operator or not. So for some exercises, there are concepts that are interesting, whereas for others, they aren't. So that was also a consideration.
Yeah, and I think we're going to have to then work out what to do with that. So it might be that, say we've got community solutions and we add like a filtering thing, so you can filter by community solutions. It might be that we add something in the exercises config that says these are the tags that you should filter by in community solutions. And so although every exercise might return whether it's using the exponent operator or not, we only actually care about that for grains, and that's marked up with the exercise.
I had already thought of that too, so we're thinking alike. So that's a good point to begin at.
So there's lots of things, like, as you can see, Erik and I are just making this up as we go. Welcome to how Exercism tends to work.
This is how we've built
things. I'll put this out. Yeah, I'll put this out, and if people have got any suggestions about this, we can discuss it on the community call as well. I know Erik won't be there because Erik's too busy playing tennis nowadays to come on our community calls. But yeah, I'll collect some data from that, and we can discuss it. But yeah, if you do have any thoughts, like, we're still in the fact-finding phase. But the reason we wanted to get started with recursion is that feels like just an obvious, solid starting point where we can get the community like building the stuff that we know is going to be used. We know for certain we'll use recursion as a detection point.
Yeah.
And then we can work out some of the product side and the UI side that supports that at the same time. Do you want to show us a bit of this proof of concept, Erik?
Yeah, sure. That's big. So I already, basically everything that was in here except for these lines of code was already there. So the C# representer, what it does is it loads the source code, and then it has multiple syntax processes. So syntax visitors, syntax rewriters, whatever. But the idea is that you have a class, and I'll show it here. And that class inherits from C# syntax rewriter, and you don't have to you can remove any code in it. It's all valid. But it has all sorts of overloads, and all the overloads are the AST nodes. So there's something about a struct declaration. There's one for a switch expression. There's one for if statements. So I would only have to pass in the code, which I do here. So the syntax is like the entirety of the tree. So I would create a new class instance, and it would say visit. Then all the logic for actually processing through going over all the nodes in the tree, that happens for me. I just need to say, well, I'm interested in this bit, and then I want to do something. So you can see that this is really easy for detecting whether or not somebody's using a for each statement. This is guaranteed to be correct because this is the same code that the compiler is actually using to compile your code. So that's good. Not all languages have an official AST parser. Some have unofficial ones. I'm always quite baffled by what Ruby does, but
Ruby has
sorry about that. But
official and unofficial. I mean, the one we use for the analyzer and representer in Ruby is quite similar to this. it's not quite as nice.
But this visitor pattern is very, very prevalent amongst compilers.
And it's often how you write languages. Like
but
when we've been looking at writing our languages, Erik, this is the visitor pattern what we've used for that.
Indeed. So then for recursion, I am sort of cheating a little bit because in C# you basically have two types of trees. One is the untyped syntax tree. So these are just, well, the general nodes. There is no typing information or whatever. So it won't know that a certain invocation, a method call, refers to that specific method. So it doesn't know that. There's also a typed syntax tree. Then you get all these bits of information. For example, you would know that, hey, this is a call to this system function. So you can be very exact, very specific. I don't use that because in general, the untyped syntax tree is enough. And it is way faster because I don't have to compile things, because the typed syntax tree requires me to compile things. So that would add like 4 or 5 seconds each time I'm calling it. So I was thinking about how can I just detect recursion on the syntax level. And the not so clean effort is this is when an invocation expressed, so like when you call a function or a method in C#, this is being called. And then there is a sub property of that node, which is expression. So there can be lots of things, but I'm now just checking for whether I'm extracting the name of the function that's being called. So if we have foo, the name will be this. So this will be the invocation, and this will be the identifying name. This is not correct because you could have namespaces, etc. But proof of concept. Then in C# you can either have a top level method. So it has no parent. The parent is the class. So there is no method. It is you don't have sub methods, but you have local functions too. So I do have to account for the fact that you could also have a local function. So this is what this is about. So I'm trying to see if this invocation, where is it defined? In which method? Is it a method or is it a local function statement? That is this bit of code. So if we have the foo example, there will be something like void is not really interesting for recursion. So interesting bar. So the parent would be bar here. And then the second thing that I do is just checking whether the name matches. So in this case, foo and bar don't match. But if this was a bar call, I would have an invocation where the name is bar, and it is defined in a method also named bar. And that's the definition of recursion. So I'm sure there are edge cases that I don't catch, but I'm not convinced that I should go to the type syntax tree just for these couple of exceptions, because I think there will be very there'll just be a couple basically, and I can obviously do some hardening of this code. So let me just run it on a bit of code. So this is the code that I will run it on. So it has the classical recursion example factorial. I am contractually obliged to use that because otherwise you get a lot of flack. So I run this, okay, and then in the file in the directory itself, I have the output, which is representations of JSON, and it detects that I'm using if statements and recursion. So if statements and recursion, it has detected it. So if I would change this to just do this, wouldn't be very helpful function, but okay, then it would remove the recursion bit. So, and that's all there is to it, basically. I have to write it to the JSON. Well, that's probably something that most people will be very familiar with. But the code's not that hard. So, and I'm happy to help, of course, if other people.
Yeah. There's going to be a sort of set of pragmatic decisions about how complex and deep to go with this. Mm-hmm. So, you've said, let's not get ridiculous. Let's just say if a method is calling itself or a function is calling itself, that's recursion. Obviously, we could also say, well, if a method calls a method, then calls the original method, that's still recursion. That's less common. It maybe matters less. There's, levels of metaprogramming you could get to where you've got, an anonymous function that's calling itself that gets complicated. Like, there's a whole load of stuff, and it would be easy to never actually ship anything because we're trying to make it incredibly robust. I think the key is let's do what you've got there, which is like define that simple first case, take that as our starting point, get that working end to end. I think
this will be
one area
where the whole recursion case, or even more. So, just think of this will already be incredibly helpful to the student to filter. If you've ever browsed community solutions, you'll know how incredibly helpful this has the potential to be. So don't try and make this 100% foolproof.
Yeah. And I think as well that where a more valuable thing would then be to have like something like tail call recursion and adding another concept for that, which would be a more complex addition, but actually is like valuable to a student who can then suddenly see, well, you've got optimized recursion or not optimized recursion. Obviously,
it's not even that hard to detect, but
no,
and some languages do that already, but
yeah. So I think, being pragmatic about where we make these decisions, I definitely think like having all of the visitor nodes like you've got there, where you're tagging this uses ifs, loops, whatever, is like a low-hanging fruit of just getting something going. There's a question as to how valuable that's going to be, which, and I think there will be a case where it's valuable in some exercises, but it's such a low-hanging fruit, it's probably an easy thing to add straight away. But I think starting with
I just
a slightly higher level concept like recursion feels the best place to me as a thing to do. Gone.
So one thing that I just thought of was that this could be those low level concepts could be really useful for concept exercises, because you want people to use a specific concept, and often that's a very low level concept because you're starting out with the basics. So there it could be really useful to verify that the student did actually use it. I know that when I did the Elixir track, I get these analyzer warnings of errors. You didn't actually use the concept that we were teaching you. I was like, geez, yeah, I did, I did cheat a bit, but so I really like that. So we could also use this for that.
Yeah, another thing that could work well would be to detect what packages people are using as well. So, we often have people who try and use, pandas in Python to do something, and we want to encourage them just to use native Python to do it. And in fact, it won't run in our test runner. But, there are situations where, you've got date exercises and you don't want someone to use the date library. You want someone to, you don't want someone to, well, maybe for leap, you want to tag whether they've used the leap method or not, or the built-in leap year function or whatever. Like there's lots of examples where we want to detect if they've used a built-in function, detect if they've used a package. And so it might just be something like, again, outputting the list of packages as a starting point is a useful thing. So yeah, lots to go on. We're going to put a blog post, forum post thing together. We'll ship this video out with it. I might also just put this on YouTube as well, just to give people a bit of a taster for what Insiders content is and why you should all support Exercism and come and join Insiders and get to see me and Erik talking about this stuff.
Who doesn't want that?
Who doesn't want that? I mean, that's what the good life is like.
I see people lining up already.
I'll put it on Insiders. I'll probably also put it on YouTube. We'll discuss it on the community call this week. And Erik and I will make some decisions in the next 24 hours about whether this is going to go in representers or analyzers, whether they're going to be called tags or concepts. And then we'll firm all that up. I'll check that nobody hates what the decisions we're making on the community call, and you can point out all the reasons that we've made mistakes, and we can then amend stuff before we put the final post out. But then this should be something fun to get going with next week. And as Erik said, he'll be happy to help out. He loves this stuff. So, yeah, cool. All right. Thanks for watching, everyone. Thanks, Erik, for your time. I know you've got a dash now. We'll catch you all soon. Bye.
Bye, everybody.